Let's kind of quickly get started. So we have with us maybe large gathering, very representative. So we just like to introduce. We have with us Pratik Kapadia. So Pratik Kapadia is the CTO at Flytex. So how many of you heard of Flytex? Okay. So Pratik will definitely help us with, I think what he is doing and what Flytex is doing, what kind of problems they are solving at Flytex. We also have with us Mario Nova. So Mario Nova is also going to help us with his perspective of how the data science as a space is shaping up, what he does and how he sees the road ahead for data science globally and specifically how it is shaping up in India. And we have with us Sudhir. Sudhir is a co-founder and also the CTO at IndusOS. At IndusOS. Have you heard of IndusOS, the company? Okay. Nice. You also switch to a fantasy. Yeah. Fantastic. Nice. So it's one of it's a bootstrap company early stages.
No, we are venture funded.
Right now, but I think you guys really started.
Yeah.
Yeah, I think it's one of the from purely entrepreneurial ecosystem perspective. IndusOS is truly one of those success stories that we are kind of seeing right now. They're doing some unbelievable, unreal stuff when it comes to data sciences, and we will give us a sneak peek into the same. We also have with us Pratik. So he's Pratik Srivastav. He's Pratik Kapadia. So Pratik and we also have Pradeep. They are also with IndusOS and they also help us understand what they're exactly doing. This is what a truly practicing data scientist looks like. You can imagine yourself becoming something like this. If you are like, if you're slightly heavy, you need to become fit. That's it. Perfect. So guys, let's get started from initially, if I just could invite Pratik, if you could just maybe take a couple of minutes and speak about what you're doing at Flytex. That would be fantastic. What Flytex typically does, and then I would kind of invite Sudhir if you could help us understand this. Pratik.
Welcome all, and thank you to the team. Flytex builds analytics software as products. We have all our services are add-on to the product. And what we do is build customer experience enhancement solutions for customers around the globe. The challenge that I see with data science as an industry today, and we are all co-contributors to that industry, is that we find it very hard to define and to encapsulate data and analytics products. Skills that you guys have and you guys will develop over the course of next few weeks will lead to you developing products for somebody in the future. And I would like you to have the perspective that what you're building is going to be a product. It's going to be shipped. It's going to be valued by the person who is using it, and it needs to scale. It needs to be built so that your skill can be used in 10 or 100 instances, not just for the instance for which you're building currently. And that is the endeavor for Flytex. Flytex wants to build products which enable model factories. Flytex has its own model factory when it does software as a service for the product for the way I would lead the technology is to build products that can instantiate many model factories. We can have more questions on this, make this interactive, I'm sure. Not all I say is possible in 2 words. Why would you
No, I mean, my responsibility within Flytex is the Senior Vice President for Analytics and Consulting. So basically, it's the services that we provide our clients once the technology and the product is there. So basically, look at the problem from the user end of it. I'm the one, and my team is the one that sits down actually with the commercial and the marketing teams that are eventually going to be using the models to create value in what they're doing. So that is what we are trying to do in Flytex, which is to connect the whole line from the inception of an idea that comes usually from a business problem. That idea has to go all the way back to data scientists that actually understand that idea, develop a solution for that idea, right? And then the whole process all the way back to the person that had that need, understand how you have solved the idea and actually implement it. There is some gray area in the middle that needs to be bridged, and that is where actually the beauty of it all comes, right? Because you're going to have people that have a blend of skills, not just purely technical, analytical skills, but you're going to have people that in that model factory that Patrick was mentioning, that actually understands the business and understands the language and the problems of the people that I'm trying to solve, that are trying to solve in a specific problem. Right? So once you're able to completely have an ecosystem where that line is seamless, that's what you can package. That's what you can actually make a model factory that produces value on a continuous basis to the people that develop the business. So, from a Flytex perspective, what Pratik will comment in more detail is what happens at the more ground technical, analytical, more the R&D side of it, of taking what we're doing in terms of candidates, analytics, etc. From my side, what I was going to tell you is what are we doing in Flytex to actually have all of that effort actually becoming something that generates value in the business.
Alright, okay. Our story is a bit different. Okay.
If you would introduce yourself.
Yeah, sure. I'm Sudeep. Just like a lot of you guys, I just did my engineering. It just happened to be from IIT Bombay. And after that, I've been running a entrepreneur. I've always been an entrepreneur all my life. After a couple of startups, some worked, some did not, whatever. Okay, and we basically have been working exclusively in the mobile space. Me along with a couple of co-founders, Rakesh and Akash, and we have been working together since 2007. Okay, and interestingly, when we always had some passion towards mobile. Right when they used to be very small little phones. Okay, and from that time we have seen how the mobile industry has actually changed, and it's still changing. Okay, it's changing at a very high pace, and that's what has always got us highly interested in this mobile area. And when we really looked at the mobile journey, and in particular the smartphone journey, a lot of countries, at least countries like US, China and all, they almost have reached that 80% kind of penetration levels when it came to smartphones. India never really, today it hasn't yet. So that sort of got us intrigued. Why is it so? And when we really started looking at the depths of this problem, what we really understood, initially we attributed that probably the cost. India probably can't afford it. But then the price of smartphones has already been slashed to such lows now. You can get a very good smartphone starting at 2.5K as well, 2.5K, 3K, and if you are ready to pay up to 10K, you can get a monster in your hand. So that problem has already been solved, but yet that magical adoption never really happened. We actually did a bunch of surveys. This was way back in 2014. Okay? We actually did a bunch of surveys. We actually spoke to people to people in the industry and particularly retailers and all. Okay, the kind of feedback that we really got is most of the people are like, I mean, what can a smartphone do to my life? Okay. And they sort of have this some form of ignorance or some kind of frightened, I mean, they're sort of frightened from the smartphone, or sort of feel that it's something for advanced people. The kind of perception, it's more of a perception. But as said, we all know that it is something which can definitely enhance your life. Okay, you can do things a lot more efficiently, a lot more faster. I mean, that's something which almost everybody should have access to, right? I mean, I want to watch a movie, I mean, I should be able to watch it anywhere, anytime. Okay, it's a very simple thing, right? Okay. So that's what got us into this particular, and what we actually said that, what we found out that we actually need to tweak the entire smartphone as such in a fashion that, I mean, any Indian and normal Indian can definitely understand the deep city. He can actually operate, and that's where the birth of Indus Reservation is. It's been a couple of years since then, and very interesting also. Interesting things that we have learned over these couple of years. Okay, how people perceive the smartphones, how they actually operate it, okay, and how they actually look at those things. And data has helped us a lot in all these aspects essentially. And with respect to data science, we initially started looking at data science when we actually wanted to solve language problems. Okay, language problems that we find. Now we need a spell checker, or for that matter, we need a. I mean, these were still easier for us to solve. I mean, we did not like we had to crunch huge chunks of data on those. Okay, and then when we started seeing post 2015 and all, we started seeing that a huge amount of interest in enterprise-based forms. That's when we started understanding that data is not just about looking at it and doing analysis, and it's a different thing when the quantum of data really increases. I mean, the initial problem that we really needed to solve was data ingestion. It was not data science or build models on it, or the first thing that we really needed to solve was basically how do we basically ensure that all this data is actually collected, warehoused, structured, organized, in a fashion which is actually workable. I mean, at the end of the day, work. But I'm saying workable because there's lots of cost also. I mean, cost factors also are extremely important in all these aspects. Yeah. And in particular, we sort of collect a TB of data in a day or two. So at that scale, things sort of go out of proportions. Okay. And starting there. That was the first problem we solved, and now we have graduated gradually to actually trying to gain more insights, wherein we are using a bit of data science to actually recommend things, to actually analyze and actually tell, define if there are correlations between these areas and others. So, and there are a huge number of use cases wherein we actually deploy data science-based techniques essentially. And the way we really see data science is it's not, I mean, it's not an exclusive data scientist job. Okay? It is something which almost everybody should do, because at the end of the day, it is math that you are really applying to deal with the data that you have at hand in a better fashion. So that's how we actually perceive data science. That's how we think that data science should actually be deployed. And that's where, I mean, I guess Iterative is doing a great job at making data science available to more and more people, and I guess they are doing a great job at that. Okay. That's what actually got us interested in working with Iterative. I guess I'll leave it there. Yeah.
So Sudhir and IndusOS is industry partner for us. So as a part of going through this whole program, you'll actually be able to see some of the problems that these guys are trying to solve internally, and possibly get your hands on some of those, maybe not the whole data set, small piece of it, and be able to attempt a lot of it. That will give them an insight. Okay, how are these guys who are shaping up able to look at the data from a fresh perspective, take it on, and move from there, and give you a perspective of what the real industry data set looks like beyond the simple Titanic and Fisher, the small data sets. So that's the thing. I think you made a very quick point, like you have TV scale data set, and every 2 years. That's what you said. Yeah. So I think if you could just help us, what is the volume and the quantum of data that typically you look at? Is it like TV scale again, or is it like?
Yes. So if you look at just telecom data or some of the largest banks, you will see about, I mean, one operator in India will generate about 4 to 5 billion events a day. Each event, even if you present it in 1,000 bytes, it's going to be total. So yes, that is what you will see every day, and it also depends on the way you want to, how quickly you want to react, how much of the stream you can hold on to until you make a decision. So certain decisions you have to take extremely quickly, like Amazon has to give you a recommendation when you're on the site. You can't compute the recommendation after you viewed the product. 2 days after you viewed the product, it sends you an email saying, hello, this is also good. It has to be on demand. And today, the kind of challenges are also with fast moving data. Even though you have one TB, only, let's say, 10 GB of that will be fresh. It means 10 GB of that has new insight or is creating an alarm which is telling a change, something about a change in the user. Finding that 10 GB, telling in that huge haystack, finding that needle is one of the big challenges.
I mean, now just to give you an example, the problem of managing 40D of real-time events is just a question of scale. It's just convince your client to invest in those machines. But finding out which one of those 4 billion events you have to do something about, it's something that you cannot decide on your own. It's a collaborative effort of a lot of people. It's interacting, once again, like I said, with the commercial teams and understanding what is it that you want to do. Okay. What is it that you want to do? You have to sit with the marketing team, we're talking telecoms, for instance, like, what do you want to do? Okay, I want to improve the experience of my very high value customers. Okay, what does that mean? You have to drill down a lot into the product and find out, okay, yeah, and end up after all of those discussions, finding, okay, what I want to do is, if it's a very high value customer, the third drop call that he has in a day, I want my customer care team to call him, apologize, and give him a free hand. That means that's when you have that information that allows you to start tuning your system to actually find out that trigger, which is the maybe that third drop call for a high-value customer is just 0.002% of the 4 billion events that happen in a day. So that's how you that's the intellectual process that happens from having 4 billion events a day to knowing what 2 billion you should do actually something that has value to the business.
Thank you so much. So, I think, and if you could just introduce yourself and what do you typically do, and what's a day in life for you looks like in this organization?
So I'm Pradeep Srivastava. I work as a senior data scientist at Indus. Like what Sudhi said, I'll build on that. So let's say we are building this feature for keyboard, right? So my role there would be like Sudhi would come to me and like we'll discuss, okay, this is a new feature we'd like to have. Like, let's say we want to have autocorrect or next word prediction, something like that. So it starts from there. Then we go to the product team. Do they have a benchmark for that? And do they? Then we use a team to find out what kind of data we have. Can we use that, or is it private and we cannot use it for making your global models? Then the business side as well as the product team also knows that there are constraints like, okay, the keyboard must respond in this much amount of time, right? So once you factor in all that, you have to make decisions upon what kind of algorithms or techniques you can actually use, right? So that part of the process, which is something you always have to keep in mind, right? Because if you look at next word prediction or any such application, you'll find 10 such off-the-shelf algorithms. To figure out what fits your needs is actually one of the sort of hard things to do, and translating them to actual mobile phones, the deployment process, how these will be updated and all, also play a big role in how the user experiences the product. So the things which you'll learn in data science are not just limited to your algorithms and maths, but it will also evolve around all these other stuff which have to sort of incorporate in your thinking. So that is what we try and do at this.
Hi, I'm Ajit and I lead the analytics team at Iterative. So just to build upon what Mario said, so for me, data scientist is not one person. Data scientist is a team which works, in sync. So somebody needs to understand the business, why we are doing this. Somebody needs to know what maths is going to get into that, and somebody needs to know how we're going to scale this up for millions of users, right? So whenever a new problem comes to us, whenever we are trying to solve a new problem, the first thing that we ask is why we are trying to solve this problem. What exactly is the need of the customer for which we want to do this? And then we sequentially drill down into, okay, what is the data sets that we require? Figure out whether we have that, we don't have that, can we use a different proxy for that? Many other different ways, how quickly we can get this data from the customer, what would be the whole data pipeline would look like, ETL pipeline. Once all this is figured out, what is the data required is figured out, we go to the modeling team, we go to basically Pratik tells us, okay, this is what it needs to, this is the model which we need to put in for this particular problem. And when that is happening, we are pretty sure that this model is going to work. We go to Sudhir and team for the tech part where he ensures that the whole scaling up of the things happens for millions of the users. So not one person can do all of these different bits of pieces. So we need to work as a team for a data science. As a team to work, we need all these individual people to come in and contribute to make that one project fly. And at Indus, that's what we are doing on a day-to-day basis.
So I think I also presume that both of you may also be getting involved in some of the hiring decisions, to actually interviewing candidates. Does that also regularly happen?
Yeah.
You look forward. Can you just help us understand, what is it that you look forward to for a candidate, what the hiring process typically is all about, and can you just give us a sneak peek in that? And so if you could just take it forward from there, what was the unicorn with the right, you put out the right, personal price that you have, and Mario and Pratik round off. So you can start with.
So in terms of what kind of skill set a user, candidate needs to have, what I normally look into is pretty, a common sense. What exactly is data, and what kind of information can you extract from the data? That's the only thing that understanding of the data is, I think, is the most important thing that one needs to have before, even going down into whether you can do Python, whether you can do Scala, whether you can do any other tools. Because these are tools which will enable you. But before you getting enabled by a tool, you must understand what exact data are you capturing, and how can it be, processed to get that particular information that you want. So understanding of data flow is something which is very important for being in this data space, and that's exactly what I try to figure out.
I think it was come for me, and you explicitly check for things like what you have a foundation in stats, foundation in maths.
So in a
how
way,
you do it.
so in a way, yes. So but usually it's not. So usually we do telephonic interviews a lot. So at that time it's not possible to actually drill down in the maths. But what we do try to do is figure out whether the candidate knows whether certain algorithms are suitable for it or not. In a way that, okay, do you know why you are applying this, and what are the limitations around that method, and so that sort of tells us, okay, whether this person can think in scale or not, or whether he's thinking about whether so in a sense that the response constraints will be met, and the deployment constraints will be met. Are you thinking around these things also? So learning, let's say a linear regression or a k-means is fine. So we do drill down into that. But before we sort of have a sort of filter that you know what you're doing. Can you answer why you are applying this method? Or once you have taken this decision, how do you sort of put a feedback loop around it so that you can improve upon it? So how sort of this whole product life cycle in terms of data science. So what I feel is, if you are good at or even decent at maths, you can always learn a new technique which is solving your problem. Or always there are new research papers and everything which is coming in, and you are anyway upgrading your skills. So maths is something which you have a decent foundation, you can build upon it. But reasoning, that process of reasoning is something I've seen like people miss out. But they don't ask why they are applying. Okay, you can apply this, and there are 10 other things also. So why not that? So that is where we focus.
To reiterate, I would just say get your basics right. See, Ajit has been saying, and you need to picture your data in your mind essentially, and you should know your data. When before trying to apply something, know your data. So that's extremely important. Okay. And because unless, see, the rest all are just tools, right? I mean, you just run some random tools. And in particular, when it comes to machine learning and all, it will always give you some output. Okay. Whether you call it good, whether you call it bad, that's a justification which you do later. But these tools, they'll always give you some output. Okay. So you can always apply. Nobody can stop you from applying. That's a very interesting problem statement. We are actually working with this field as such. That's one thing. And of course, I mean, as you need to have a bit of that math background, essentially. And trust me, all this is 12th class maths. As long as you can basically plot things like and plot things in multi-dimensional space and visualize them, it's more than sufficient. And the rest of it is just plain old stat, averages, means, and standard deviations, and just these things extrapolated to quite a bit. Okay, so that's something which, as long as you're good with your 12th class math, I'm damn sure the rest of, I mean, understanding individual algorithms and all should be very easy for you guys. Okay. Apart from that, I mean, it's important that you actually analyze, given a problem. I mean, don't really jump to conclusions. It's extremely important that you actually analyze, study through, understand what the actual problem statement is. Okay, many a times, I mean, somebody might just come over and say, hey, I just want to increase my revenue by X, Y, Z, blah, 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 whatever. I mean, that's what generally a business guy would always come up with to you. Okay, and I mean, when before even answering that, I mean, yeah, I mean, definitely apply some machine learning and all. Okay, so I'll give you one example. Okay, so we have our own store, an app store called as Apple App. Okay, and on this, I mean, of course, even in India, WhatsApp is the most popular app. Okay. So we want to increase downloads on our app. Very simple, very obvious. And everybody who doesn't have WhatsApp app, just show him WhatsApp. It's bound to download. And increase your downloads. But are you actually, is it beneficial to your store as such? Will they keep coming back again and again and again? Okay. I mean, he's bound to download WhatsApp irrespective of whether you show it, you don't show it, right? I mean, you might recommend it, your model will tell you, okay, fine, if that doesn't have WhatsApp, so show him WhatsApp because it's the most popular app. Okay. But it's not beneficial, right? At the end of the day, that's not. And what we really learned from our set of users is because our set of users, they are not the kind of people who will go look for stuff. Okay. They do stuff. I mean, they just end up doing stuff, whatever you show them, whatever you give them. Okay? They are not quite knowledgeable. Okay? So, in this sort of a scenario, I mean, you need to show them stuff which could delight them, not which they know exists and you are just showing the same thing again. Something which would delight them every time they come back. Okay. I mean, yeah, net. So that's what I'm saying. It's not. It is insufficient to actually look at only the map basics. You also need to look at the entire holistic picture. Extremely important. What are the real problems that you're trying to solve? You many a times you might have to basically rephrase your problem statement to achieve actual goals.
Even in some cases, you have to break it down into smaller pieces which you can solve them individually but not as a whole. So that is something which you need to think.
So essentially, it's a lot of thinking that we really look at how you're really thinking, how you're applying your head to it. That's the bottom line.
And if you could just outline the process, you like first telephonic, then in person, then written.
We don't have, I mean, we are a startup, okay, so let's be practical. We don't have a strict process as such, okay, and at the end of the day, what really matters to us is the candidate really game enough to actually work with us? That's what really matters to us, okay, and is he actually inclined enough? Skills and all those things, I guess they are necessary, but the ultimate thing is, I mean, we really understand and the large goal that we are really chasing.
So I said at the beginning that I would give a different perspective to all this, and probably I'm gonna surprise you a little bit with my answer of what I'm looking for in a candidate. What I'm looking for in a candidate actually is heart and soul and passion. In our process, in my team, I have a PhD in analytics who heads the analytics department. I know that when he interviews the candidate, he's going to do all the checks and ticks technically. So why do I say that I'm looking for heart and passion? And I'm going to go around a little bit on my answer so you understand that I'm going to tell a personal story of how did I arrive to analytics. I come from a completely different background. I have a major in economics. I did an MBA. I've worked all of my life in telecoms and technology. But I started my career as a management consultant, McKinsey style, suit and tie, etc., etc. Used to interact with CEOs, thinking about a strategy. All right, you have to acquire this company and do this and do that, etc., etc. So that's what I was doing for the first part of my career. This big fish, strategy, etc., etc. So analytics was something that was kind of I didn't even heard about it. I started my career back in 1998 in consulting. I was doing consulting, etc., etc. Then comes 2005. And some people that had left the company called me and says, "Hey Mario, we've just joined this very exciting startup. You have to come work with us. This is the coolest thing ever." we're in the music industry, and you love music, so you have to come to the music industry. What are you talking about? And then they set up an interview with the CEO, who was a PhD in artificial intelligence from Barcelona, that had set up this company in Corvallis in the US, in the state of Oregon. And then I have this long meeting with this guy, and this guy blew my mind and opened a whole new world. He says, yeah, the story about this company is the following, right? This is year 2005, okay? It's 12 years ago. Nothing that we're discussing here was even a concept, okay? So yeah, the concept of this company is the following. See, Amazon has just revolutionized online shopping. They have just started to do recommendations. So if you have bought this book, you should also bought this book, because people that are buying this book are also buying this book. And he says, and you know what? That's bullshit. It's really bad. We can do it so much better than that. And especially for music. Yeah, what do you mean it's bullshit? That's great, No. What they're doing is they have an algorithm that takes purchase patterns and gives a recommendation. And that's really bad. Why is bad? I couldn't understand why he was at. So look, it's a polluted taste profile, because you can buy for yourself or you can buy for your grandmother, and then on your profile there's a book that has absolutely nothing to do with your taste. So that data point is meaningless. Or you buy two books, you love one book, you hate one book, and then those two have the same weightage. So you may be recommending based on a book that the guy actually hated. So those recommendations sometimes are good and sometimes are bad. So what happened? How did I come up with this idea of music recommendations? When I moved from Spain to the US, I had to leave my music collection behind, my CD music collection behind, and I have become a compulsive buyer of online music on the iTunes store. And I've realized that the iTunes player has a counter of how many times you listen to a song. That's the key. That is what allows me to create an algorithm that actually tells me what your taste is in music. Because if you listen to a song 50 times, you like it more than if you listen to a song 2 times. Then I can start making connections in songs and start understanding what songs are related. Right? Because I can see how many people like these 2 songs. So basically these songs are very well connected, and then I can do recommendations. Right? So the amount of and he was just trying to solve a problem there. It always becomes so the amount of passion that he displayed when he explained how the idea was originated absolutely blew my mind. Right? And I decided to join the company, and it was from 2005 to 2007, end of 2007, 2.5 years, 2 of the most fun years that I've ever experienced. We went into going from just music recommendations to actually create music communities, because if I know that particularly myself have the same musical taste that we don't know each other, I can put the 2 into connection. So I go from music recommendation to people recommendation, and then we did products for actually bars and discotheques, where an automated system would receive SMSs from the people in the venue, because it would be advertised on screens, and people would say what music they wanted to hear. Then the algorithm would gauge what is the taste in the room, and then would automatically play the music that is not adequate for people in the bar. And then you could send SMSs. Very, 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 very fun times. So in the end, passion was the component. Okay. And it was then in 2005 when I understood what applying analytics to these is amazing. And I got into analytics when I went back into consulting. Then I really got into applying analytics back to telecoms, and then I did my study, I certified myself as a SaaS modeler. I got into modeling, and that's how now I am doing what I'm doing in finance. So the passion element of it is fundamental if you want to have a career in this. Because like I was saying, there is a moment that you need to connect the actual problem. You need to have that drive to solve something. In my case, yeah, music was one part of it. Telecoms is another part of it, and that's why a number of years afterwards, I'm still here in this in the system industry, applying analytics to try to solve problems. Maybe some of you have a passion for photography, and then the path that you get is into the amazing things that analytics are doing in order to recognize what's in an image, analyze it, and think about comments. Maybe it's cars. A Google self-driven car generates 4 GBs of data that it uploads to the cloud every hour. Every car, every hour. The amount of things that you can do with that is amazing. From insurance, okay, the insurance agent doesn't want to know how good of a driver you are. If you accelerate very fast, you brake very fast, or if when you or the sensors on your parking, if you stop when you are 10 centimeters away or 2 centimeters away. All of that information can define whether your premium for your insurance is high or low. Or supply chain management, all the sensors in the engine can tell when a piece is going to break, and then the right alarms can go so the production makes sure that a piece is going to be on the workshop when you got your car for service. So going back to what I am personally looking for, I need to identify some kind of passion for telecoms, because in the end, you either have a passion of what you're doing, or you're not going to be able to see the human face of numbers. Okay. Numbers are just numbers, but you need to see that behind those numbers there are actual people behind doing and interacting with systems. So you're just not looking at numbers for the sake of looking at numbers. You're trying to identify how people interact with an OS, how people interact with the art, how people interact with the phone. You're trying to define what's over and beyond those numbers. So you need to have some passion for what you're doing. In the case of telecoms, you have that passion of, for instance, when a data set comes to you, you're not going to understand anything. You need to have some kind of knowledge of what is telecom, what is ARPU, average revenue per user, what is on-net voice, off-net voice, on-bundle data, off-bundle data, all those things. If right now I give you guys a set of telecom data, if you've never been exposed to telecom, what are you going to do with it? It's going to have something like 200 fields. It's like, what does this say? What does it mean? How do I clean that data? How do I transform a variable if I don't know what the variable actually is? How do I decide if I leave it as a continuous variable or if I use labs? You need to understand the business that you're into, and you need to understand the problem that you're solving. And for that, you need that kind of passion to keep you going and be engaged into that problem for long. So otherwise, if you just looking at numbers, there's a point where you're going to get bored. So what am I looking at? Yeah, passion. And find your passion. Find your passion. Look for it. Because if you couple that passion with the ability of using numbers to impact on that, then you have fuel to go to get going for a long time.
Thank you so much, Mario. Pratik, if you could help us answer the same thing, but from a services perspective and a product perspective. You're hiring for a services company, from a product company, your experience across the industry, not just for data science.
Okay, so I will take the high now. So, let's look at the way, what each of you here. You are here because, I may be completely wrong, but you are here because there is a way that needs a certain niche skill. You want to acquire those skills so that you write today. Right? We exist and we call ourselves doing data analytics now, partly because we are riding the wave. And so let's look at this economy and the way it works. So the economy is an economy that has extreme skill shortage. That you know, the academia, cloud, other providers want to fill, and that's one side of the market. The other side is the demand, where they want to quickly fill skill, and of course, obviously as a human being who is part of an economy, who is contributing as part of the workforce, we need to be extremely talented, extremely passionate, and we need to understand our environment, we need to understand business. But let's face the facts. Today, why we are in this economy? We are in this economy because there is a shortage of skills. Okay? Imagine the future, not very far away. Somehow, either the skills will pass on to a machine, or many of the skills that we call extremely highly skilled jobs today, first will be data engineering. Today it is extremely highly skilled. Data engineering will not be ETL. What we call data science by writing many lines of interesting code that combines algorithms. It is very likely that machine learning will solve the problems which are repetitive, which are measurable, which are predictive. And you, as the audience, have to fit into this evolving market. And think about what you need to do to stay relevant for the next 5 to 15 years. How your career will grow when the market and the economy evolve. Not all the answers are there. I certainly don't have an outlook to 5 to 15 years and exactly what path each of you should follow. But the first thing you must look at is how you can make your work repeated. Whatever you do, you build so that it can be shared, that it is collaborative, that other people can pick up and build on it. And if you have to do it again, you require 1% of their effort to do it again. In another scenario, with another customer, with another so-called data set. The first step to preparing for your future is to make sure that you make what you do repeatable, as repeatable as
Do we have any questions that we can take? We'll be more than happy to, we can keep it interactive. Yeah.
So the data that you receive, it could be from customers as well, right? Now, what if you want to get the information over the internet? So there could be different sources of information that are putting on the internet. What if you want to collect that information? How do you know how one could do that?
you want me to think?
Yeah. So.
Okay, so this is very, very extremely automated right now. You get tons of web crawlers. You can download and use. You can build your own web crawler in less than a day. And there are custom web crawlers for crawling tweets. There are web crawlers for crawling images. These are products that. These are basic tools of the trade that you must know. I can't point you specifically to that tool, but you do. Google is good enough.
So in that case, since you have that huge amount of data, how is that one can be able to find that exact sort of data that matters? Because over that period of data, you have so many different variations and there are deviations. How do you try to find an exact sort of data that will really matter. What would be your thought process in that?
Repeat.
Yeah.
No, no problem. So I have one perspective. That's why I would like to contribute. So today the way we look at it is there is if we are talking about public data, the meta information is improving as we speak. The indexing is improving as we speak. What was page rank is much different at any place. But one way to do it is to customize your search. If you have to customize your search, you need to train your search engine. There are extremely clever ways of training search engines. Now you have interfaces also which are voice. On voice you can call for what you want. But is your question, how do I find the data that is relevant to
So,
me?
yeah, to give an example, suppose you wish to find information for a particular product or for a particular company, say for example telecom for that matter. Now, you will have many user preferences of different operators,
Yes.
and different operators will have different programs for voice and data. Now, if in case you want to find out what a particular set of people would like to have as part of their data operators or their data programs, what would be your thought process? Would you be looking at the different set of people that you need to focus on, the data, the age, the ranges, the differences, a particular set of people perhaps, a particular set of regions? What would be the thought process that would go into this? What I'm doing?
Yeah, I mean, the question is that once again, you start by the definition of the problem. All right. You were right when you were trying to do a specific problem. You have to start that, and then it's going to be a case by case process. What is it that I want to understand? All right. So if you sit down with the guy and say, no, I need to understand how the product that I have just launched, okay, how is it being perceived in the market? All right. Okay. So good. So tell me the name of the product, tell me the variation of the names of the product, so you have what you're looking for. And then it's actually the talent of the data science is fine-tuning what it's looking for, what is going to give you the richness of what you get back. Because when you're doing this one, then we're going into a lot of text analytics, which means that the key is basically what you're looking for. So all of the processes to understand if a sentiment is positive or negative is linked to a specific word, to specific words. Okay? So for instance, how good your algorithms are being able to define contradictory sentences. Like for instance, we do have a demo that has voice recognition, all right, for us to be able to propose an offer for you. So the automatic voice says, would you like to subscribe to this package? Says, that looks interesting, but not now. So there's a part of the sentence that has a positive sentiment to it, and a part of the sentence that has a negative sentence to it. How the data modeler solve those kinds of problems will determine the accuracy whereby you're going to be able to answer the question that the client posted. Is people liking my product or not? Obviously, free speech is going to have these kind of contradictions, and those are kind of the problems that you're going to have to solve in order to say with certainty to the client, yeah, like 72% of the people like it, right? And the other don't like it. So that's kind of the process that goes into it, because depending on what you're looking for, then you're going to have to fine tune those things. It's case by case. It really does depend on the question that we're trying to answer.
Thanks, Mario. Maybe you would like to add something?
So, quite often you will find that, so basically, as Mario said, you need to understand what exactly you want to solve. And then the next question that comes on, what is the data that you require? Now, at this point, what you'll find is there is a data set, there are a lot chunk of data that you don't have or you can't use, privacy issues, you are not able to take that. Then you start looking into what is the proxy I can use, which can actually imitate or give me those same signals which that particular data probably would have given me. Just to give an example, you as a user, okay, I want to figure out how economically good you are. I mean, how much financial strength do you have? One thing is your bank account. I don't have that information. What can I use as a proxy? Probably if you're a prepaid user, what is your account balance? That particular information probably I have, and that is something that I can use to model you into. Okay, you are a very you have a very high balance. You are a higher bucket than somebody else. So you have to think around what kind of proxy things that you can use to actually solve what was your main goal. So to be very honest, you will not find data. Okay, I want to solve this, and I have this particular data set for which I will solve this. It's not gonna happen. You need to think around what kind of data set can help me into solving this problem. Do I have it? Do I not have it? If I don't have it, what can I use as a proxy? So all this thinking, logical reasoning actually goes into before you actually run an algorithm on a particular text.
So you should be able to compare oranges with apples in some cases.
Yeah, you have.
Let me reiterate on that point. See, I mean, there might be some public data sets. Public data sets, there are lots of social media and all. Nowadays, there's no shortage of data. But many a time when you get public data, you also need to spend a lot of time and basically identifying just, what makes sense out of that. Okay? And that is much more time-consuming, effort-consuming, and of course, when you're actually doing the things at that scale, you also need that kind of research. So, if there might be a lot more simple things which are more easily available at hand. Okay, so let me just give a very simple example. Okay, so things like what kind of data plan to offer to a particular user. Okay, it's I can of course we can always go run social media. How often is he actually going on? Is he downloading a lot and kind of thing. I mean, you can of course get a lot of data from there, no denying. Okay, but unfortunately, to actually process that kind of data, you'll have to spend a lot of time, effort, and you also you might also get things there which you didn't want, but yet you are actually getting. Okay. But on the other side, if you're just looking at fine, how many times did he really just overshoot his data plan in the past in the past 12 months, or something like that, you might actually end up getting a better gauge of it. Okay, if he's overshooting often, then he definitely needs a larger data plan. Okay, that's a signal. That's definitely a signal. Is it the same signal as how much he wants? The answer is no.
In general, the biggest challenge that we have regarding open data is the actual usability. Because the product that we were saying before is the easier part of the problem. So it's a client coming and telling you, is the market liking my product? It's been solved, we do it, we know how to do it. The next step, which is the really impactful from an economical point of view, is how can a telecom operator actually use that data, right? Because in the end, what they're going to be able, they're going to want to do with open market data is things like, hey, I want to classify my people into early adopters, laggards, etc., because they are expressing themselves in social media in a way that I can do that. But why do I want to do that? Because maybe to my early adopters, I want to treat them in a different way, offer them several things, give them their address, whatever it is. But for that, what I need to do is actually link a Facebook ID with his with his actual telephone number, and that is where the challenge comes in, and that is where everything related to privacy comes in. So, can we do sentiment analysis on open market data? Yes, absolutely. But it is mostly what we call non-PII information, which is not personally identifiable information. So the question is, how much use can we do with it? How much value can you extract? In the end, if you remember, we're on 5 cents actually model is from data to actual value. How can you actually use the data to value? The challenge, the biggest challenge, and there are ways around it, yeah? You can do it. But the biggest challenge of open market data is how you use it. And how much value can you extract.
Thank you so much, Mario. Thank you, Sudhir. So, I think all of us were aspirants of data science at one stage. And if you were to just go back and give yourself one advice from 10 years ago, this is what it is. Can you just probably share maybe one thing that comes to your mind? Do this thing right, and you'll get right. There's something that comes to your mind. So we can start with the thing.
So, looking back, there's the subject called linear algebra. Like it seems very easy, and like you can take it to the very last day, and like you will still get very good numbers. I would say that like linear algebra would be something which you will really encounter in the next few months. Like you see that okay, this is where most of the things happen. And calculus too helps, but mainly linear algebra will solve a lot of the problems along with statistics. So that is what I would like to focus on. Like, if I had known, like, okay, so I would have focused way more on, like, okay, who has learned better, be better at linear algebra.
So, I don't come from a scripting background or who I can who can code basically. I'm more from the business side and how the data actually what information can be derived from the data. I come from that background, more from the business analytics. So I would have said to myself, get at least hang on on one of the scripting language, because once you get one language, it's very easy to start learning the other one. But unfortunately, I never got into coding as such. So at least one of the scripting language should help you out in.
The thing if you could share one thing you have in your mind you want to tell maybe younger yourself.
Yeah, I'm completely idiot. I didn't have anything in mind. But I mean, for me, in handling large data sets, I was handling large data for 10 years ago. Now,
For you, maybe 15 years back.
What would I say? I would have taught myself to be more flexible. I used to think that when I started, I used to think that the data science was going to give me an answer to a question. Like, it was going to be like a very point-to-point thing. So what years have taught me is that you need a great deal of flexibility, especially when things that, like Pratik was saying, that you need to actually understand that the key for your models to be successful is going to be replicability in different in different cases. In our case of telecoms, for instance, as a company that we work with many operators, many different telecom operators in many different countries. So the Mario of 10, 12 years ago when I started with this would have approached a problem of churn prediction. I would say, yes, these are the attributes that I need. This is the transformations that I need. This is the best algorithm, and this is the best. And then I would go kind of very proudly say, yeah, this is it. And then I would be kind of very bully and try to have everyone do it in my way. But then with time you realize that, okay, you go, yeah, you develop this one for this kind of media, but then you go to Mozambique and, well, half of the attributes are not there. What do I do? It's like, or, and you find that every time, and then you have to go back to the drawing board and then you start the model actually from scratch. Because you find out that the model that you did and that worked wonders on the first case, you try to do it in another case and it completely fails. So from the start, you start with the mindset, okay, I need to have this model working on a large variety of cases. Then you take much more attention to things like, an automatic variable selection, or having model algorithms, and then selecting the algorithm that works better in an automated way. Then you don't build your stuff in a way which is very rigid. So flexibility. My 15 years ago was a little more stubborn.
So, I don't come from a stat background, I don't come from a data science background. I'm originally an embedded engineer, okay? That's how we ended up making an OS. Okay, one thing which I would probably see myself as, start paying attention to data. That's what I would have basically told myself a long time back. Back then it was more like get things done kind of. Okay, but there was never that that long-sightedness of, there could be a lot of things that this data could do for me and down the line in the future. So let me start collecting it. Let me start looking at it. Okay. So that's one of the things. Because we started this thing late. Okay. What happened? What practically happened is all of a sudden we got lots of data, and we are in this situation where now what do I do with it? Now what do I do with it? Okay, so that's all I would basically say. That we start paying more attention to it. You need to. Data has a voice of it, okay, and you need to hear it.
So, possibly have very little time, but we can take maybe a question or we have a question.
How much time it takes from deciding, okay, I this feature to all the data set, getting the data set, average?
Depends on the product group, but usually it takes about 1 to 2 months to have, at least 1 month to have a prototype, right? And prototype in the sense that not just running on the laptop, but running on an actual device, and probably a few more things to go along so that we have a clear idea on what kind of data usage are we going to require, what kind of update patterns, cycles, and these things take a bit of time because they know a lot of other teams. So approximately 2 months at least is where you end up when you have the devices rolling out the actual data models. So yeah, around 2 months. Yes. That may vary.
See, 2 months if you're only looking at building the models and
You know what you are doing.
That's
not a
it.
vague problem. You know exactly this was the problem and this is the specification of it. So if not, then
If you don't know that there is a data set that you have and you don't know what resume, you will have some routine that you
yeah, you have to do a
if
lot
I
of
don't
things.
understand anything about this,
Yes.
then I usually do this and many times I get it.
Sort of exploratory analysis is something you have to do.
A lot of
Irrespective of your
complicated
application of backtest from there, you actually get to know whether this data is of any use or not. So you might be collecting a lot of data, but it might just be just everything might be just related like it's because of one dependent variable, everything moving similarly. It's just one thing which you are collecting, but as in you are collecting 10 things, but it is just ending up as a single signal. So if one increases, everything increases, then there's no point having any variation in your the data collection process itself has a problem. So in that case, you have to go back, collect new data, so the process becomes much more long. The faster you realize the kind of data you're collecting is right, the better it is. So once you have that, okay, you have the right data, then it takes roughly about 2 months to finally hit the market.
Sandeep?
Yeah. So my question is that, as you said, that you are from a more sort of business background and you don't really have good hands-on any programming or scripting language basically. So what advice would you like to give to basically, in certain cases it's vice versa, like I'm from engineering background, I'm a programmer. So what are the advice that you would like to give to programmers or the coders basically, from the business perspective, that things that we should get in order or we should get a good hang of those things, more sort of from the business perspective and not actually thinking from the engineer perspective. So what's your
So
advice?
again, like I said, data scientist is not one guy, it's a team that is working. Okay. You may be very good at coding and everything, but you may not understand the business side of why are we doing this. So it actually comes from logical reasoning, thinking around, having discussion with the team, having discussion with the person who is, why exactly are we solving this? Once you know that why, we are doing this, then it gives you a much better clarity on how do you write the code, which algorithm you want to use. Because with that why, all the other constraints will come, right? The model should run in so and so time. It should give at least 80% of accuracy. I mean, those are some constraints which actually, comes when you start answering that why. And that actually comes within the team when you start discussing, because you cannot understand the business as good as what a business guy can, understand. He cannot write a code as good as you can write the code. So data science is basically, a team effort rather than an individual who, gets a data set, runs some code and gives you a model. Because as Sudhir said, every model will give you some answer. Whether it's a right, wrong, it all depends on what exactly you want to solve. And once you figure that out, by discussion, by getting into, the problem as such the user is facing, I think, then it's more, because in terms of time, if I actually tell you what his question was, how much time does it take? So it practically takes 10% of the time to run the model, to run everything. But it takes 90% of the time to actually get to that why, to understand why we are solving it. And once you do that, collect data, figure out that the data is right, and then you run the model.
I think you would like to add.
Yes, so I agree wholeheartedly with Rajesh. And since it is collaborative sport, we talk about with passion. One skill I would definitely include in an engineer's repertoire is communication. You need to learn how to communicate outcomes. You need to learn, because communication is about knowing what the other person, how the other person wants to hear, what he wants to hear. Those are things that I am an engineer. We as engineers don't have that by default.
So basically, as your day-to-day as an engineer and a percentage of time in front of a computer, you may expect individual data scientists to spend much less time in front of a computer, much more time interacting with your teams, interacting with your clients, discussing solutions. So the percentage of time of human interaction is going to increase. So your human interaction skills, presentation skills, communication skills will definitely need to improve.
Okay, one more question.
So when we put a real-time pipeline of data in production, what are the favorite technologies or stacks you look at, how to compare them? Like after you decide an algorithm to be implemented in production in real time.
Yeah, I see. This is a very interesting problem. Okay? I mean, Spark has been, in a very short answer, Spark has been a preferred choice in particular to for real-time data ingestion and actually analysis. Okay, but many a times, I mean, the question is about when you're saying real-time, you also need to know how real-time. I mean, you want it within seconds. Okay, if you want it within seconds, even this path might not actually suffice because the central server or whatever the central system that actually on which your Spark is running might actually be located somewhere else. Your data is actually going there, it actually needs to process, do something, and then finally come back. But if you really need an answer within an instant, you might need to actually run your models right where the user is, right on their servers. Okay. So there, I mean, a lot of different things come in picture. Okay. It's not just about, you might need to actually write your own custom model running in code actually to ensure that the model is able to run on a very small mobile device. Okay. Or for that matter, you might and many a times you might not need so much. Okay. Many a times your real time is something like a couple of hours. Okay.
Basically, you need to have what trade-offs you are making. You need to know that before you write a code, okay, these are the trade-offs I'm going to make, and this is where my system looks like this. And that will sort of give your business team as well as your data science team roles to like manage their expectations in terms of users as well as the kind of accuracy of expectations from the data science team.
We have one question from Deep online. So he's asking us, what is the typical mix of skills in data science teams today? How do you think it will evolve in 5 to 7 years? And what do you think will be more relevant? Will it be technical or domain? And then finally, what does the pyramid look like? So that I think from a more IT perspective, we typically work in pyramids, large teams.
So, can you hear me?
Yeah.
Thank you for that question. That makes my presence on the panel relevant. So I truly believe that domain-specific data science, domain-specific data engineering, domain-specific analytics is extremely short-lived, and we as the currently skilled workforce need to make sure that we remain domain agnostic. We build so that we can replicate, and I would again go back to build as if you're building a product. Build as if somebody is going to consume it many months down the line, many miles away, many conversations away. So these Chinese whisper conversations, you should still have an end outcome which is understood, and package it as best as you can. That is what is going to make it relevant. The packaging will get smarter. The packaging will be done by more by machine, less by human as we go forward. But start packaging now.
This is an interesting question, especially in the context that you hear a new tool come up every 6 months, okay, and now you never know whether it will be able to make an impact or not make an impact. Okay. Let me just give you a larger industry outlook on all of these tools, systems, or frameworks, or whatever it might be. These things, there's a different industry war going on as such, whose systems will basically rule the data science in the future. And whoever basically wins that war, I mean, at the end of the day, there might be only 2, 3 which will end up actually surviving. So that's the reason why you actually see this lots of tools coming up every 6 months. But irrespective of the tool or whatever it is, what is really important is it's not the tool itself, it's how the tool functions that you really need to understand. Okay, what is it that the tool is really doing? Okay, there might be an analytics tool which is just plotting things for you. Okay, it's probably just a graphic engine. It's just doing a graph. Its relevance will always be there. Okay, you should always remember that looking at graphs is something that people have been doing for the past 50 odd years. Okay, and they'll continue doing it forever practically. So, as long as you understand that this tool is allowing you to graphs, I mean, it's a very good tool to actually look at graphs. You actually are looking at that and that tool limited to that. Okay. And tomorrow there might be a different tool which comes up that says, oh wow, I mean, I'll let you do analysis in an entirely different perspective. I mean, it auto runs models and whatever, and then it actually shows you things in an entirely different fashion. Okay. And that's what is happening in this piece is even more competitive in today's world. Okay? Because the graphing problem has been more or less solved, and there are a ton of graphing tool circles available. And so this is where there is even more new. This is more of a new area where a lot more high level wars are being fought. And when Facebook brings out its own tool, Google brings it out, and there are a ton of other smaller companies which are actually trying to compete in that space. But irrespective of which tool does what, if you really look at it, every tool is actually geared to do something really well. A very interesting example would be Google's TensorFlow. It is rightly suited to do deep learning. So if you're trying to do a regular age-old clustering kind of thing using TensorFlow, you're probably overkilling it. So which will survive and which is the next thing? I mean, practically, because with the age of war in the next 5 to 7 years, almost all of them will be relevant. Okay. But what is more important as such is you use the right set of tools and frameworks based on what your need is. That is actually much more important.
Thank you so much, Sudhir. I think we have run out of time, so probably we'll just kind of conclude over here. So, Rajiv, Prateek, Sudhir, thank you so much. Prateek, thanks for your time, sharing all your insights that you have. What we're going to do now is we have lunch. So, kind of request all of you to join us on the 7th floor. We'll be ready in around 10 minutes. You can help yourself to lunch over there. And we'll also request the panelists if you are request you to kind of join us for lunch if that's kind of possible. So thank you so much. Thank you so much for coming in. Thank you so much for willing to spend time with us.